Yeah, let's continue to the extension to the previous class. We did all the basic concepts of a three-dimensional geometry, like distance formula, section formula, area of the triangle, tetrahedron, coplanarity, collinearity, parallel, and all this we did. And even the equation of the straight line also we have seen, and we have compared vectors with three-dimensional geometry. And I gave you every formula of three-dimensional geometry from the window of vectors. Now, similarly, we will be continuing this with the straight line here. So let me share the screen. Now, this is the straight line. So, straight line in the space. What is the difference between the straight line in two-dimensional geometry and the straight line in the space? See, straight line in the space is formed by two planes, please. If you are sitting in a room, and in that room, if you see the wall adjacent to you and the top, which is ceiling, if you see that ceiling is a plane and your adjacent wall is a plane. If you see that ceiling and wall adjacent to you, they are intersecting in a point or in a line. Respond, please.
Yes, sir.
They are intersecting in a line or a point. Two planes intersect in a line or a point. My question to you, please.
Two planes intersect in a line, sir.
Yes, that's what the practical example I told you just now. Take a wall in the room in which you are sitting and take the ceiling. That ceiling is a plane and the wall adjacent to is another plane. These two planes are intersecting in a line. So 3D line is nothing but the intersection of two planes. Understand that. Important point, please. Important point. If you take any two lines, two-dimensional, if you take any two lines, two-dimensional, if they are non-parallel lines, they intersect in a point, please. This is one line, this is another line. These are intersecting in a point. But if you take one plane, this is one plane, let me say. And let me take another plane, which is like this. Now, the question what I asked you, if these two are non-parallel planes, then they intersect in a line. Just observe it, please. Both of you. They are intersecting in a line. So, this is nothing but 3D line. And this is nothing but 2D line. So 3D line is the intersection of two planes, understand that. So standard format of plane equation, line equation in two-dimensional geometry, you tell me first of all, let me understand. What is the line equation in two-dimensional geometry standard form, please? Ax plus by plus c equal to 0. Correct or not? Now, the extension to 2D line is 3D plane. Remember that. Plane is always 3D only, three-dimensional. Of course, plane, if you take the plane individually, plane consists of only two dimensions. Now, if you take any two planes that are non-parallel, that comes under three-dimensional. Now, always understand all the 2D line concepts are just transferred to 2D line concepts will be just transformed to plane, please. Plane.
Okay, sir.
Remember that. It starts from its standard form. What is the standard form of 2D line, please? Respond. What is the standard form of 2D line? Ax plus
Sir,
by
plus C is equal.
plus c equal to 0. What is the standard form of plane, please? Ax plus by plus cz plus
D is equal to 0.
Just understand this. Understand this, please. So what I'm saying, every concept of 2D line is just transformed to 3D plane. Just a moment, please. So yes, please. From the straight line 2D line standard form, every concept of 2D line is just transformed to the plane. You can clearly see that here itself. That is, if you have the equation of 2D line containing only x and y terms here, and it consists of x, y, z terms, that's only the extension. So if you see plane from the window of 2D line, it goes very easy, and vice versa. That means if you see the plane, if you see the 2D line from the window of plane, it will be easy for you. This is important. So now, if you want to understand about 3D line, first of all, you must study plane, because plane, when you know about the plane only, then only you can understand about the 3D line, because line is the intersection of two planes. Line is the intersection of two planes. Anyway, I'll make you understand that easily. See what happens when you want to represent a 3D line, when you want to represent a 3D line, how 3D line is denoted. How 3D line is denoted. It is denoted with two plane equations. That's it. It is denoted with two planes. One is a1x plus b1y plus c1z plus d1 is equal to 0. Other one is a2x plus b2y plus c2z plus d2. So if you see this type of equation anywhere throughout three-dimensional geometry, you have to understand that it represents a 3D line. So understand, 3D line is denoted by two planes. Then what is that information we have about 3D, this line of intersection now through the planes, This is an important point, because this green color plane, let me say this is first one, and this some chocolate color plane is with second one. Two plane equations are there, we accept it, no doubt. But these are intersecting in a point, in a line here, which is said to be 3D line. So 3D line is denoted by these two equations. That's okay. But what information we have about 3D line here? It is the intersection of these two. But if I want the DRs of that line, how do we get it? How do we get it? Very important point, please. Very, very important point throughout the geometry, throughout three-dimensional geometry. This is a very, very important point. Understand that. If I take a normal, to the first plane, let me say this is the normal. Normal means, it is at 90 degrees to the plane. Okay. Now, if I take another normal to this plane, okay, that is, let me say, this is another normal. Normal means it is at 90 degrees to this. Now, if you find out the cross product of these two, if you find out the cross product of these two lines, then whatever the vector you get will be parallel to that line. Whatever the vector is there, that will be parallel to this line. Let me explain you. This is the most important concept. Most important concept, please. See here, carefully. If you understand that, that line goes very easy for you. Okay. Now, let me show you that. One moment. Yes. Now, for example, this is one plane. In the three-dimensional room, you're obviously everyone sits in a three-dimensional room only.
Yes, sir.
Obviously, roof will be there, and the four walls will be there, and the floor will be there. Okay. So whatever the concepts of 3D are there, it is better you compare everything with whatever the room you are sitting. See, for example, I have taken this plane and the top ceiling. Now I have taken a normal to this plane, the adjacent wall, and I have taken normal to the ceiling. These two are like this. These two are like this. Now, if I find out the cross product of these two vectors, I repeat, Kaushik, if I find out the cross product of these two, then how the cross product or vector product should have a direction. This is one vector, this is one vector, this is another vector.
Perpendicular to the plane.
Yes, that's right. So this is the plane, this is the plane.
Yes,
when this is a plane, normal will be, perpendicular will be like this.
Yes, sir.
Now this is parallel to that line of intersection. This is parallel to that line of intersection.
Yes, sir.
So how do you get the information about the 3D line using two planes is like that. You have to take the normal to the first plane, normal DRs to the first plane, and normal DRs to the second plane, and find out the cross product of both. Then you will get the information about the line of intersection of the two planes. This is what you have to understand. Okay. Now, if you see this, what are the normal DRs? Normal DRs of the first plane is nothing but coefficients of XYZ, that is A1, B1, C1. Normal DRs of second plane is nothing but coefficient of XYZ, A2, B2, C2. You have to find out the cross product for this. That is, you will get IJK here. Determinant form, I need not to tell you that, IJK. If you find out the determinant for this, B1, C2 minus B2, C1, comma, this one. Next, C1, A2 minus C2, A1, comma, A1, B2 minus A2. This is what you have to understand. So how to find the information about the line of intersection of these two planes, you have to find out the cross product of the normals to the plane and the normals of the normal DRs of the first plane is A1, B1, C1. Normal DRs of the second plane is A2, B2, C2. We have got the determinant of this. That is, I'm getting I'm getting the cross product of this. So cross product of this gives you the DRs of the line of intersection of the two planes. I'll take a numerical example so that you'll better understand it. Follow this carefully, please. This is an important concept, and if you understand this, everything in 3D goes easy for you. Now, let me take a plane 3x minus 2y plus 4z plus 1 equal to 0. And another plane 2x minus y plus 3z plus 4 equal to 0. How many planes are there? Respond, please. How many planes are there?
So 2 planes.
2 planes are there. And is equal to 0 means when 2 planes are given, if they are intersecting planes, what is the information we need is we need the line of intersection of these 2 planes. We need the line of intersection of these 2 planes. This is first plane, let me say. Okay, now second plane, let me say the other one. This is second plane. Now they are intersecting in a line. This line I'm representing with yellow color. We need the information of this. Then what is to be done? I said, you take the normal to the first plane, you take the normal to the second plane, and if you find out the cross product of this, whatever the cross product you take will give you the DRs of that line, which is parallel to the line of intersection. Which is parallel to the line of intersection. That means parallel means when you take the cross product, that will give you the DRs of that particular line. How to get it? Simple, very simple. 3 minus 2, 4, 2 minus 1, 3. And of course, you will write IJK here for the cross product. Just I'm reminding you that in the objectives, we don't write all of that. We just take the DRs only. So here in this case, what is a line vector here? Line vector minus 6 plus 4 minus 2i. And it is 8 minus 9 minus j. And it is minus 3 plus 4 plus k. That's it. So what are the DRs of this line of intersection, please? Now, what are the DRs of line of intersection? Minus 2, minus 1, 1. That's it. Minus 2, minus 1, 1. I hope you understand what I'm explaining. Are you there, both of you? Please respond.
Yes, sir.
Yes, sir. There, sir.
Okay. Now, this is one way of understanding 3D line. And another way. Vectorial form, please. Vectorial form. In the previous class also I explained it, but I'm repeating it. This is R bar is equal to A bar plus lambda B bar is one form. And similarly, R bar is equal to 1 minus lambda into A bar plus lambda B bar. One more form. How do you understand? Very simple, please. Follow this carefully. What is the meaning of it? A line is passing through a point which is A bar. And parallel to another vector B bar. This is the information. This is the data, I must say. This is the data given. Similarly, in this case, what happens, there is a slight change in this one. Whatever, the line equation needs 2 items in the data. Line equation needs 2 items in the data. This is a line. It passes through A of A bar and B of B bar. Okay. Now, this is the information you have. So, What is that I said? Please respond, both of you. What is that I said about R bar? Very important point, please. R bar is
A plus lambda B.
xi plus yj. If we want to convert this to 3D form, R bar is a general point in vectors, Kaushik, and xyz is general point in 3D. This is what you have to understand. Okay. Now A bar, let us take it as x1i plus y1j plus z1k. Plus B bar, parallel vector is generally taken to be AI plus BJ plus CK. This is what I explained in the previous class. Now, come on, tell me, what is that you get if you take I bar common x minus x1? What is that you take common if j bar is taken common y minus y?
Y minus y1.
Z minus z.
Z1.
And by A you will get. By B you will get. By C you will get. There is equality in between. Is equal to lambda. So both are same. You have to understand that. Both are same, please. Okay. Now, similarly, if it is passing through 2 points, if it is passing through 2 points, then it will become like this. Passing through 2 points means you will have x1, y1, z1. You will have x1, y1, z1 here. And x2, y2, z2 here. Okay, then what happens, do you tell me, any one of you, please, what are the DRs of AB?
Sir?
What are the DRs of AB? If A is x1, y1, z1 and B is x2, y2, z2. There is a difference of these two. Or AB bar is nothing but OB minus OA.
Y2 minus y1 z2.
So, if it is passing through 2 points, this denominator will be simply replaced by x2 minus x1. And here, y2 minus y1. Here, z2 minus z1. That is only the difference. This is the form of two different forms of a line in three-dimensional form. This is called parametric form. Why is it said to be parametric form? There is a parameter defined there. What is the parameter defined there? Lambda. Lambda is the parameter. So this is called parametric form. Then what happens, you'll be getting a general point like this in this case. Cross multiply, please. A lambda plus x1, B lambda plus y1, C lambda plus z1. If you want every point at any point on the line, you will be getting this in this way. Cross multiply and write x, y, z from this one. This is frequently used in three-dimensional geometry. What is that frequently used? Let me write that for more clarity. For more clarity, what I'm doing, I'm writing the most general point which we use frequently in three-dimensional geometry is the cross multiplying and writing it in the parametric form. You'll come across this. Follow this carefully, please. Come on, tell me now, what is xyz from this one? xyz, please. x1 plus a lambda. Pranit and Kaushik. y1 plus b lambda. z1 plus c lambda. What is the importance of this? What is the importance of this? Yes, there is a lot of importance for this, because if you take a line, this represents every point and any point on the line. This represents every point and any point on the line. That is the reason why We take it as a general point. And to write every point at any point on the line, what is the data you require? You need a fixed point on the line x1, y1, z1. You need a fixed point on the line x1, y1, z1. You must know the DRs of the line ABC. You must know the DRs of the line ABC. Kaushik, are you there?
Sir.
So this is the most important point to be remembered in working out the problems. Okay, so we have seen two different forms for the 3D line. Number one is the Cartesian form. Let me say it as Cartesian form, which is represented by two planes. Line is 3D line is the intersection of two planes, and the parametric form is seen on the screen. These are the two different forms for the 3D line. Okay, let us now see the related theory. This is now the straight line in the space. Let us check it out. Let us revise it, what we have learned, so that you will be more comfortable in remembering this. Just visualize this. This is which form it is? X minus x1 by a, y minus y1 by b is equal to z minus z1 by c. It is called symmetric form. He said it as symmetric form, not Cartesian form. In fact, it's not Cartesian form. Cartesian form is the line form, and because you will have lambda here, lambda is missing. Lambda here, it is said to be the parametric form. This is a parameter. And then in the vectorial form, it is r bar is equal to a bar plus, this is missing here. R bar is equal to, just now I said a bar plus lambda. Where b bar is a vector which is parallel, just see this, which is parallel to the given line. And a bar is a point through which the line is passing through. This is one form of the equation of the line in the vectorial form. And these are just now I discussed, which I said very, very important is this. X is x1 plus a lambda, y is y1 plus b lambda, z is z1 plus c lambda, which is very, very important, please. And it represents every point and any point on the line. X1 plus a lambda, y1 plus b lambda, z1 plus c lambda. Okay. Now, this is given to be the Cartesian form here. X given. This is what I explained you is when the line is passing through 2 points. I said the denominator is replaced with x2 minus x1, y2 minus y1, z2 minus z1. These are nothing but the DRs of the line. In place of ABC, you will get this. That's it, nothing more than that. And I think below you are given the vector form. This is the vector form. R bar minus A bar is equal to lambda into B bar minus A bar. This B bar minus A bar is nothing but x2 minus x1, y2 minus y1, and z2 minus z. Now, changing unsymmetrical form to symmetric form. How to change it, we will be working out that in the problems. That means when two planes are given, how to convert it to the parametric form or symmetric form. That is, there is a method for that. Solving the equations method. We will be learning that. No need to learn it as a formula, but we can simply understand that because you know how to solve two linear equations. If you know that, it is done. Okay, let us now see the problem. The equation is the straight line passing through 2 points, 4, minus 5, minus 2. And minus 1, 5, 3. Kaushik.
Yes, sir.
These are the 2 points given. Now we have to find out the equation of the line passing through these 2 points.
Equation of the line passing through the
just you need not have to by heart anything, please. By heart anything. You need not have to by heart anything. Just understand this in this way. This is 4 minus 5 minus 2.
Yes, sir.
and this is minus 153. Now, what is a symmetric form or parametric form of the line
X
x
minus
minus x1
x1
by
by
a?
A is equal to y minus y1 by B is equal to z minus z1 by C.
Correct. Now choose either A or B. It is your choice, no problem. X minus 4, y plus 5, z plus 2. The numerator is done. Now the denominator ABC is needed. And as I said, it is AB bar is nothing but OB bar minus
Plus
OA
OA
bar
bar.
is nothing but DRs, please. Seeing three-dimensional geometry from the window of vectors. From the window of vectors. Come on, tell me now. What is OB minus OA? This one. Minus 5. 5 plus 5. 10. 3 plus 2. 5. That's it, please. This is the line equation. Are there, Kaushik?
Yes, sir.
So ABC are DRs of the line, Pranit. So what we did is we have subtracted A from B, that's it.
Yes, sir.
We have subtracted A from B. You can subtract B from A also.
Yes, sir.
Makes no difference except the change of sign, and even it can also be written like this: x minus 4 by divide with 5, y plus 5 by 2 is equal to z plus 2 by 1.
1.
It can be written like that also.
Yes, sir.
Because,
Simplest form.
we can divide with 5.
Okay, sir.
That's what the equation of 3D line is. Next one. The DCs of the line, this is the question just now I discussed. We are doing now example 21. The DCs of the line 6x minus 2 is equal to 3y plus 1 is equal to 2z minus 2. He is asking for the DCs, don't forget, DCs of the line. See this carefully, please. It is very easy. Before writing the DCs of the line, let us understand the symmetric form of the line. Kaushik, please tell me the symmetric form of the line just now we have seen. X minus x1 by a
Yes, sir.
is equal to y minus y1 by.
Sir, there's a lag, sir. By the way.
Okay. X minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. Pranit, this is the symmetric form. Correct now?
Yes, sir.
Now, what he is asking is, he is asking for the DCs of this line.
Okay, sir.
DCs means these are nothing but DCs. A, B, C are the DCs. So you have to find out ABC in that case. ABC in that case. So how to find out ABC in that case? You have to make XYZ coefficients 1. You have to make XYZ coefficients 1. Take 6 common there. X minus 2 by 6. Kaushik, is it visible? Take 3 common there.
Yes, sir. No, it's visible, sir, but we are experiencing a bit lag, sir, while you're writing. Means we are hearing a word, but we are not seeing.
What is that you see now?
Yes, sir. Sir, 6 into x minus 1 by 3 is equal to 3 into y plus 1 by 3.
Come on, tell me, if you take 2 common, what is that you get in the third part?
Sir, z minus 1, sir.
Correct. Now bring this 6 to the denominator. Bring this 6 to the denominator. Bring this 3 to the denominator. Bring this 2 to the denominator. This will be 1 by 6. This will be 1 by 3. This will be 1 by 2. Now, what are the DRs? 1 by 6, 1 by 3, 1 by 2. To make them numbers, what you do, take the LCM of 632. What is LCM of 632, please?
Sir, LCM of 632.
Praneeth, what is the LCM of 632?
Sir, 6.
3 to the denominators. You are struggling a lot. LCM of 632 is 6.
1 minute, sir.
X3 LCM of 6.
Sir, 12. Sir, no.
You call your sister. She will tell you.
18.
You call your both of you call your sister.
Sir,
They will tell
I
you.
was waiting for the answer, sir. No, it's 18.
So what is the LCM of
18.
632 is 6. So multiply with 6, then you will get 1 year, 2 year, 3 year. So what are the DRs now? DRs is equal to 1, 2, 3. Now, do you tell me the DCs for this?
Sir, 1 by root of 1 square plus 2 square plus 3 square.
Correct. 1 by root 14.
Sir, 1 square.
2 by root 14.
3 by
3
root.
by root. So conversion of DRs to DCs is done like this. So these are the DCs, please. Okay. Now what is that we did? Just if you observe the problem, the equation given is converted to symmetric form, and after that we have converted the given equation to the symmetric form, and then we have taken the DRs of it as 1, 2, 3, and when you know the DRs, you can convert them to DCs like this. Clear now?
Yes, sir.
Now, let's move on to the next question, please. So the answer is B here. It's clear. Next. See, he mixed up vectors and 3D. What is example 22? Can you read that, Kaushik?
Sir, okay, sir. The vector equation of the line through the point A 3, 4, minus 7, B 1, minus 1, 6 is.
We need the vector equation. I'm not directly giving you the formula form, but I'm telling you how to write the equation. Just follow this carefully, please. Through the concept. Through the concept, please. Through the concept. Like what? So I'm taking up the explanation through the concept only. See how to write this. Follow this carefully, please. I'm taking up a point P here, which is a general point. In 3D, it is said to be X, Y, Z. In vectors, it is said to be A bar, R bar. In vectors, it is said to be R bar. In 3D, it is said to be X, Y, Z, or Xi plus Yj plus Zk. And I'm taking this as A bar, this as B bar. Now you tell me whether AP and PB, AP and AB are collinear or not. AP bar is equal to lambda into AB bar. We can write because they are collinear. Correct or not? Now, how to write AP bar? OP bar minus OA bar. R bar minus A bar. How to write AB bar, please? B bar minus A bar. Correct or not?
Yes, sir.
Now, we need it in the vector form. R bar is equal to A bar plus lambda into B bar minus A bar. Are you there, Kaushik? Praneeth?
Sir,
Yes,
Now,
sir.
do you tell me what is A bar here? This one. Come and tell me that. 3I plus 4J minus
Sir.
7K. Yeah.
After 3, I didn't see anything. Yeah, now it.
Plus lambda into B bar minus A bar. Array, Praneeth, you are also facing the same problem?
No, sir, it's not lagging for me.
Okay. So B bar minus A bar means subtract A from B, please. Subtract A from B. 1 minus 3. Minus 2I. Minus 1 minus 4 minus 5J. 6 plus 7, 13K. That's it, please. This is the line equation. And I did not apply the formula. If you remember the formula, that's great. And if you do not remember the formula, just understand it conceptually. What is that I did? I have taken the collinearity condition. And from the collinearity conditions, I derived the equation. This is the equation. In fact, if you want to apply the formula, this is the formula. R bar minus A bar is equal to lambda into B bar minus A bar when the line is passing through 2 points. When the line is passing through 2 points. And we converted this to the IJK form. IJK form because the points are given there. I think you understand this. Kaushik and Praneeth.
Yes,
Okay.
sir.
Understood this, sir.
Yeah. Now, let us move on to the next question. So, do you recognize the answer now? I am opening it again. It's gone. Oh, it is in white color now. Yeah. 3, 4 minus 7. Oh.
Hello, sir. Can you hear me?
Yes.
Yeah.
3, 4 minus 7 and the difference of these two. At a glance, you can say the answer, Praneeth and Kaushik, at a glance to this because I want to make you understand more clearly. I have written and show you, but if you want to check the answer directly, see 3, 4 minus 7 first. It is there. First option, third option contains 3, 4 minus 7. And second option contains 1 minus 1, 6, 1 minus 1, 6. Okay, you can take this also. But the difference must be 1 minus 3, minus 2, where is it? Yes, you have. And minus 5 you have. And 6 plus 7, 13 you have. So option is C here. Not the rest of them because you must have this difference. Wherever this difference, it is nothing but the DRs of the line. Next, please. Angle between two lines. What is that I was saying? I was saying that the 2D line concept will be taken straight away to the plane. And here it is, of course, lines. Cos theta formula is there in 2D line, A1, A2 plus B1, B2 plus C1, C2. A1, A2 plus B1, B2 by root over A1 square plus B1 square into A2 square plus B2 square. Here you will get extra Z. This is what the formula. And if you want to understand this in the vectorial form, cos theta is equal to A bar dot B bar by mod A bar into mod B bar. That's it. Cos theta is equal to A bar dot B bar by mod A bar into mod B bar. And if theta is 90 degrees, respond please. If theta is 90 degrees, what is the condition?
Sir, theta equals to 90 0.
Then what is the final result? A dot B 0.
A dot B equals 0, sir.
So whenever A dot B becomes 0, you can say that they are perpendicular. That's what is given as condition for perpendicularity. Most important, please. A1, A2 plus B1, B2 plus C1, C2 is equal to 0. If they are parallel, they are proportional. A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Okay. Now, next question, please. Here itself, we will understand. If you cooperate, just say this. Renee, can you please read this question? 23.
Sure. Yes, sir.
Can you read that please once?
If the lines x minus 1 by 3 is equal to y minus 2 by 2k is equal to z minus 3 by 2, and x minus 1 by 3k is equal to y minus 5 by 1 is equal to z minus 6 by minus 5 are the right angles, then k is equal to.
So you have to apply simply the condition for orthogonality.
Yes, sir.
Now you tell me at a glance, I'm giving you the entire stuff here, A1, B1, C1, and this is A2, B2, C2. Can you work out and tell me the value of K now? Please, both of you put your pen on the paper. Put your pen on the paper and tell me the value of K, please. You're taking that much time. Minus 9k plus 2k minus 7k minus 7k minus 10 is equal to 0.
Sir, 10 by 7.
It is 10 by 7.
Yes.
Simple question.
Yes, sir. Substitute.
Your option is B.
B.
So most important one is condition for perpendicularity, please. And this one also the frequently asked question, and the concept is important. Now, Kaushik, please read that 24.
The lines x equals to ay plus b, z equals to cy plus d, and x equals to a dash y plus b dash, z equals to c dash y plus d dash are perpendicular to each other. If.
Oof. Come on, tell me what is the condition for perpendicularity, please.
A1, A2, B1, B2, C1, C2.
Nothing is there in between.
Plus,
You're that much lazy fellow. You're not in a position to say plus there. Come on, tell me the entire formula, please.
A1, A2 plus B1, B2 plus C1, C2 equals to 0.
That's good. So you are given two lines here in the plane form. In the form of planes, it is given. Of course, all are same only except that AB given, A, B, C, D given, and here A dash, B dash, C dash given. Let me explain you now. If you have any doubts with regards to the DRs of the line now, it will be cleared. It will be cleared with this problem. Just see this carefully, please. What is that I'm saying? These are the two planes. Understand that. These are the two planes. Now I'm writing them in an order. X minus AY plus 0Z minus B equal to 0. Kaushik,
Sir,
tell me the other line, please. Other plane, please. 0x
plus
cy
yes, sir.
minus z
Z.
plus d equal to 0. Correct?
Yes, sir. Yes, sir.
Similarly, now Praneeth, please
Sir.
tell me the second one like this. It is plane in the proper form. X minus a dash y
A dash y.
plus 0 z. Z is not there.
Yes, sir.
Minus b dash is equal to 0. Nothing like this only, but the ABC are replaced with dash.
Dash, sir. Yes.
Come on, tell me that. Similarly, 0x
0 dot
plus
plus
c dash y
dash minus 0 minus z
minus z
plus d. D dash.
equal to 0. Now, Kaushik, how to find the DRs of this line, please? This line is made up of these two planes. This line is made up of these two planes. First line, how to find the DRs of that line? That is, you have to take the cross product of normals. Just now I explained it is 1 minus a 0, 0 c minus 1. Kaushik, are you there? So what are the DRs of this line, please? First line, A, 1, C. That's it.
Yes, sir.
Similarly, how to find the DRs of the second line? Same. 1 minus a dash 0, 0 c dash minus 1. Come on, tell me the DRs now.
Sir. A dash.
No difference between these two.
C dash.
Dash or-
C dash, sir. Dashes is there, sir.
That's all. Now, do you tell me the condition now? If they are perpendicular, what is the condition? Just now you said A1, A2,
Plus
B1, B2, plus
Yes.
C1, C2 equal to 0. That's it. That is a condition.
Yes.
So this is a standard problem, please. This is a standard problem. If you understand this concept, it will be very easy to solve the problems related to three-dimensional geometry. Most of the problems. And in fact, the line, 3D line is to be studied only after working out the problems related to the plane. But here, most generally in the syllabus, they give 3D line in the beginning, but it won't, it is not advisable to read 3D line first and then plane. The order should be like first introduction to 3D, these is DRs and all, and then plane, and then 3D line finally. But here we open 3D line in the beginning. I hope you understand this.
Yes, sir.
Okay, now let us move to the next problem.
Sir, just a minute. I'll drink some water.
Yeah.
Very thirsty.
Next question, please. DRs of line perpendicular to x minus 7 by 2 is equal to y plus 17 by minus 3 is equal to z minus 6 by 1 and x plus 5 by 1 is equal to y plus 3 by 2 is equal to z minus 4 divided by minus 2. Please understand the question. Praneeth, are you there? Praneeth and Kaushik, are there both of you?
Sir,
Yeah.
I came now, sir.
Yeah. Now the question is, drs of the line perpendicular to both the lines.
Gears of the line perpendicular to both the lines.
Okay. Now, how to find the drs of the line perpendicular to both the lines? We discussed this already. Come on, if you tell me, I'll write. See, this is one line, Kaushik.
Sir.
And this is another line. I need a line which is perpendicular to both.
Yes, sir. Sir, cross product.
That's good. So that's not the perfect diagram, but
Yes, sir. Somewhat.
yeah, I'll do it like this. These are the two lines. This is the perpendicular. So if I say this as A bar, no, this as B bar, no, this is simply A bar cross B bar. Correct, no?
Yes, sir.
What are the drs of A bar here? 2 minus 3, 1.
Yes, sir. 2 minus 2.
What are the drs of B bar here?
1, 2
minus 2.
Yes, sir.
Therefore, drs of perpendicular.
Sir, 4.
Good. Next.
3 2 means sir 6.
No, you
No,
have
no,
to
no,
cross.
sir. Yeah.
Leave the middle one and cross multiply from right side. Leave the middle one and cross multiply from right side, please. 1 into 1 plus 4.
Yes, sir.
Fine, no?
Yes, sir.
Yes, next.
Sir, next 7.
That's it. 4, 5, 7 are the drs of the line which is perpendicular to both the lines. Let us check it out, Kaushik. Let us check it out. How to check, just if this line is perpendicular to this line, the dot product must be 0. Check it out. 2 into 4 minus 3 into 5 plus 1 into 7. How much is it? Just see. 0. We are checking whether our answer is correct or not. Can you tell me the same for the second one also? Kaushik?
Sir?
Can you check the same, whether this line we have got, the drs we have got, the line which is perpendicular to both the lines.
Yes, sir.
I confirmed it with the first line, by applying A1, A2 plus B1, B2 plus C1, C2 equal to 0.
Yes, sir. Yes, sir. Okay, sir.
Can you do the same for the second line also?
Okay, sir.
1 into
1 into 2, 1 into 4. Plus, sir, and plus 2 into 5 and plus minus 2 into 7, sir.
Is it 0?
5 to 10, 14. Yes, sir.
That's it. So your answer is drs of the line perpendicular to both is nothing but 4, 5, 7. Okay. So if you want a line which is perpendicular to two lines, you have to simply find out the cross product. Okay.
Sir.
A reduction of Cartesian form of the equation of line to vector form and vice versa. This we will see in the next session. And intersection of two lines also we can understand, and among them this is foot of the perpendicular, which is extension from two-dimensional straight line to the plane. Foot of the perpendicular on a line. And reflection or image, it can be easily understood, and you can, in the objectives you can verify them. You can cross verify them from the options given. We'll complete this in the next session.
Sir.
Okay.